Today, we are going to talk about conic sections. So what are conic sections? Conic section is a shape resulting from intersecting of a right circular cone with a plane. There are 4 types of conic sections. And what are these? The first is the circle. Second is the parabola. Third is the ellipse. And the last is hyperbola. But in this video, we will be focusing on the ellipse, and specifically, the vertical ellipse. But first, let us define what is ellipse. An ellipse is a set of points whose sum of distances from the foci is a constant. So what are the components of an ellipse? An ellipse is composed of center, vertices, co-vertices, foci, major axis, and the minor axis. In this diagram, the yellow dot shows the center of the ellipse, the green dots show the vertices of the ellipse, the red dots show the co-vertices of the ellipse, and the blue dots show the foci of the ellipse. While the line connecting the 2 vertices of the ellipse is called the major axis, and the line connecting the 2 co-vertices of the ellipse is called the minor axis. What is the standard form of the equation of an ellipse? The standard form of the equation of an ellipse is x squared divided by a squared plus y squared divided by b squared equals to 1, where a squared is greater than b squared. So let's proceed to the main focus of this video, the vertical ellipse. What is a vertical ellipse? A vertical ellipse is an ellipse where the major axis is at the y-axis. What is the standard form of the equation of a vertical ellipse? The standard form of the equation of a vertical ellipse is x squared divided by b squared plus y squared divided by a squared is equal to 1, where a squared is greater than b squared. And note the differences of the equations of the vertical and the horizontal ellipse. If the numerator of the a squared is the y squared, then it is a vertical ellipse. But if the numerator of the a squared is the x squared, then it is a horizontal ellipse. So, let's have an example. The given is quantity x plus 1 squared divided by 9 plus quantity y minus 3 squared divided by 25 is equal to 1. We must find the values of the center or the h and k, the values of a, b, and c. We must find the values of these in order for us to graph our ellipse. First, we must find the value of the center. So we got the center negative 1, 3, and the given positive 1 and negative 3. We changed the sign of the positive 1 so it becomes negative 1, and the sign of the negative 3 and it becomes positive 3. Next is we need to get the value of a. We already knew that a squared is always greater than the b squared. Thus, in 9 and 25, 25 is the greater value than 9. In order for us to get the value of a, we must extract the square root of 25, and that gives us 5. Next, we will get the value of b. In order for us to get the value of b, we must extract the square root of 9, and it will give us 3. And lastly, we will get the value of c. In order for us to get the value of c, we must use the Pythagorean theorem. C squared is equal to a squared minus b squared. So, 25 minus 9 is equal to 16. Next, we will extract the square root of 16 and it will give us 4. And now, we already got what we need. The center, which is -1 and 3, the A, which is 5, the B, which is 3, and the C, which is 4. And now, let us proceed in graphing our ellipse. In our given quantity x plus 1 squared divided by 9 plus quantity y minus 3 squared divided by 25 is equal to 1. First, we must locate our center, which is in -1 and 3. Since we already knew that our ellipse is vertical and the value of A is 5, thus, from the center, we must move 5 points upward and 5 points downward. Next is we need to plot our minor axis using the value of B, which is 3. Since the major axis is perpendicular to the minor axis, we must move 3 points from the center to the left and to the right. And lastly, in plotting the foci using the value of C, we already knew that the foci is located at the major axis. So, from the center, we must move 4 points upward and 4 points downward. Using these points, we can already graph our ellipse.
So we will be talking about the real-life uses of ellipse. The shape of an ellipse is formed when a cone is cut at an angle. If you tilt a glass of water, the resulting shape of the surface of the water is also an ellipse. You can also see ellipse when a hula hoop or tire of a car looks askew. Though these are examples of optical ellipses, the ellipse also has practical uses in real life. Food shapes. Foods are cut to form ellipse, offering a fine touch to simple foods. Cutting a carrot, cucumber, or sausage at an angle to its main axis results in an elliptical slice. Wraps tortillas wrapped around a filling such as chicken salad are often cut into 2 elliptical wedges. The sharp focus of the ellipse gives everyday food a more elegant look. Whispering gallery. A focus is one of 2 points that defines the shape and size of the ellipse. They're located on the long axis of the ellipse, at equidistant points from the center of the axis. If light or a sound wave emanates from one focus of a real-life ellipse, it will be reflected to the other focus. This property is used to create whispering galleries, which are structures that allow someone who is whispering in one area to be heard clearly by someone in another area, but not by anyone else. Famous examples of whispering galleries include the United States Statuary Capitol Hall and London's St. Paul's Cathedral. Lithotripsy treatments. It is a surgery-free method of destroying a kidney stone that uses the properties of the ellipse 2 foci. For a lithotripsy treatment, the patient lies in an elliptical tub with the kidney stone aligned to one of the foci of the ellipse. Because no incisions are made, recovery from this treatment method is relatively quick and easy, and in some cases, it can even be done as an outpatient procedure. Elliptical trainers. An elliptical training machine simulates the motion of running or walking, offering low-impact cardio workout. When you walk or run in an elliptical trainer, your foot describes an elliptical path. An elliptical machine can be motor-driven or user-driven, and some elliptical trainers also feature handlebars that you can push or pull on to help move the foot pedals through the elliptical path.